Now the Venn diagram below shows the number of students who play the guitar G or violin in the class of 40 students. It says how many students play neither the guitar nor the violin. So we want to know how many students don't play nothing at all. So there are 12 students outside who don't play guitar or violin. All right, I would be, when I was in high school, clearly I would have been one of these 12 students. All right. Now, which category would you fall in? So, no violin. So 12 students don't play nothing. It says write an expression in terms of X, which represents the total number of students in the class. Now, the universal set is the total amount of students, and the universal set contains 40 pupils. And so what we have is 2x that play guitar only plus x, which persons that play both guitar and violin, plus 4, that's violin only, plus 12, and the total is 40. All right, but they said expression, so we don't need to equate it to 40. This would be the expression that would represent the total amount of students in the classroom. Then it says write an equation which may be used to determine the total number of students in the classroom. Now the equation is this same thing right here, which would be 2x, which is just 3x, plus 4 plus 12 is 16, so 3x plus 16 equals 40. All right, and that's that. Then it says now how many students play guitar. No, it didn't say how many students play guitar only. It says how many students play guitar. 3x students play guitar, so we need to find what is 3x. So 3x is equal to 40 minus 16, which is equal to 24. So 24 students play guitar. All right, I'll finish with that question. Now this part of the question says, using a ruler, a pencil, and a pair of compass, construct the triangle ABC such that AB is 9 centimeters, the angle at B is 90 degrees, and the angle at and BC is 6 centimeters. So first thing all is we draw a line AB. A line AB, this is A, this is B, and AB is 9 centimeters. All right, and then angle ABC is 90 degrees. So that means the angle at B is 90. So of course, I'm just giving you a rough sketch. So of course, you're gonna swing your arcs here. All right, open your compass wide out, swing your arcs and stuff like that to get this being 90. Something like that. But then what did the final thing say? It states that BC is supposed to be 6 centimeters. So you're gonna make sure that this is just 6 centimeters. Bring it down a touch. Make sure it's 6 centimeters. That's a triangle. Nice and easy. You can show them that this is 90 degrees. something like this you're going to construct, of course. And next part of the question says measure and state angle BAC. So this is the angle. All right, I can give you a region that BAC should be in, because if you were to use trigonometry, you would say opposite over adjacent is tan. And so what I'm saying is the tan of theta is equal to opposite 6 over 9. And this would be able to tell me what theta should be. If tan theta is 6 over 9, theta should be tan inverse 6 over 9. And so you should be getting, this I'm getting 33.7 degrees. All right, and so because you're measuring it with a protractor, because you have to use a projector to measure it, because you're using a protractor, they would take an answer generally anywhere between 31 to 35 degrees, because we won't necessarily get this accurate when we're constructing it. All right, sometimes we hand slip a little bit and we just don't get it perfect. So if you give a region between 31 to 35 degrees, you'll get your mark. You want to be as accurate as possible, but generally this should be theta, 33.7 degrees. Then it says on the diagram, show the point D such that ABC is a parallelogram. All right, so for this to be a parallelogram, what's a parallelogram? So D has to be here. All right, a rectangle is indeed a parallelogram, so D has to be here. All right, this, what happens is that CD have to be equal to the length of DA. They have to be parallel, and AB has to be parallel to DC. So D has to be right here. All right, just want to follow the properties of a parallelogram. All right. Oops, I put D just a little bit too high. So this is where D should be, not necessarily this point, but here. All right. What are the properties of a parallelogram? So generally, this is how we see parallelogram. All right. And properties of parallelogram tell us that this side is parallel to this side. This side is parallel to this side. Their two diagonals are equal in length. All right, and a rectangle is indeed a parallelogram, so D needs to be at this point. All right, nice and easy.